Hello, very good evening. A warm welcome to today's session on how to learn differential geometry. I welcome you all to my channel Physics for Students, and I hope my audio is clear. Just a quick check, those who are watching, can you just put it in the comment box that whether my audio part is clear or not? Just a yes will be very helpful. Is my audio part okay? If you can just let me know a yes or no, then we can start with today's session. So the basic idea of making today's session is that differential geometry definitely is a very clear. Okay, differential geometry is a very important subject which we not only deal with pure mathematics, students of pure mathematics, but it also becomes very useful when we are learning physics, higher end dimensional analysis, topological analysis, general theory of relativity, Riemannian geometry, and lot. So in today's session, what I would like to give you is a complete guideline in order to understand, know the books, process, methods, difficulties, and then how you can learn differential geometry. Now, a quick note before I start that in today's session, I will be talking about multiple books. So each subject will have 3 or 4 or maybe 5 books. The reason why I'm doing this is that you might find one book not to be useful or costly, or you might not find these books. Now, if you want to know where you can find these books, you can contact me later in my email. Some of them are available in archives, some of them I can send you. That is not a big problem. But don't get confused that why I am saying so many books if one book is sufficient, because in my experience I have seen that always one book is not sufficient. Maybe one book is speaking of this particular topic which is good, that particular topic which is good. So don't get confused if I show you multiple books. This is point number one. And also, you don't need to read through all those books. You can just take one of the books, but the reason is to give you multiple options so that you can find which book is right or wrong. So first of all, I would quickly give you an idea about what is differential geometry. As we know, that differential geometry comprises of two words. One is differential and is geometry. Differential means that we will be using heavily calculus, differential, integral, etc. And also we need to know a lot about geometry. Now, hold on. When I talk about geometry, what I'm trying to tell is that from the Euclidean Cartesian school level geometry, those who are learning MSc mathematics or you are going in physics, higher dimension and manifolds, this geometry will be a non-Euclidean geometry, obviously. So in order to transit from Euclidean geometry to non-Euclidean geometry, it would be a little bit difficult. Visualizations, etc. These becomes a little bit difficult. So I will also give you an idea that if you're reading class 11, 12 or BSc level Cartesian, on your Cartesian level geometry, then what are the books and what are the preparations mentally that you need to know to go to geometry. So here we would be talking primarily about non-Euclidean geometry. So here you can see that differential, we would be primarily using calculus and differential calculus, and geometry, we will be learning about surfaces and where we can use this calculus to underline the surfaces. So why differential geometry? Because it is a branch of mathematics that focuses on the geometric properties and structure of the tools of differential calculus. Now, here you will have a lot of questions, I understand, which you can ask by the end of the session. Differential geometry, topology, which one will I learn? Shall I learn topology or not? All these questions I'm going to answer in today's session. So we learned what is differential geometry. It will be using heavily calculus and heavily geometry, not the usual geometry, but non-Euclidean geometry. But what we also need to understand is that what is the reason of learning differential geometry? I mean to say, why will we do that? Instead of learning other areas of mathematics, why will we learn geometry? Well, there are a huge amount of usages, but I have just listed few of them which will give you a motivation. So first thing is that you will definitely understand calculus better. Whatever, if you're doing physics, mathematics, geography, share market, whatever, if you're learning calculus, then using calculus in an applied kind of a thing like differential geometry, you will be learning the calculus much better. Second is that fundamentally understanding very complex concepts becomes easier. Also, you will see that because differential geometry deals with Namaskar, Rudra. So also because differential geometry deals with lot of theorems like Gauss-Bonnet theorem, etc. Many theorems are there. That means your problem of enhancing the problem solving capacities, that is much, much better. It will depend your understanding of space. Here by space I'm trying to tell is that the curved spaces, the straight lines, etc., how things are deformed, etc. So the overall idea of what you see around your world, the space. Yeah, good evening, Shomajit. So overall what you see around your world, that will be changed. So space does not mean only what I mean to say, only things that you see around you, but you can close your eyes and you can start thinking of higher dimensional space. For example, 2D, 3D, 4D, or 5D dimensional space. That is the usage of differential geometry. So with one subject you can go into many areas. Even if you go into machine learning, etc., high dimensional space, high dimensional arrays, this will be something very useful. You will see that it will connect to physics. Obviously, general theory of relativity is depending on differential geometry, robotics also, computer graphics, AI, data science, genetic engineering, and a lot of things. So you can understand that this is very, very important, not only for the study of mathematics, but to, sir, I am in only class 11. Can I learn this topic? Yes, absolutely, Shomajit. You need to watch through the entire session. And I can tell you, Shomajit, if you watch this session and you start learning differential geometry, in class 11 also, the level of mathematics that you are doing, whatever, calculus, differential, integral, that will also be better. Because harder the concepts, the your exercise will be more and you will learn better. So class 11, good time to start with non-Euclidean geometry, Shomajit. Right. So that is why there are many implications: genetic engineering, AI, data science, etc. So this will give you a motivation that we are not wasting time just listening to me or studying such difficult things or complex things and beautiful things. So that is why we need to learn differential geometry. Okay. Now, as I have told that we need to learn calculus, so the question comes that why do you need calculus? I mean to say, you all understand calculus is very, very important. But in terms of differential geometry, why calculus is important? So first thing you will see that differential geometry actually uses lot of surfaces, lot of shapes, curvatures, etc. So this part of our video you can see on this slide, it actually gives you a lot of learning on how to apply calculus on the manifold. Don't worry if you don't understand manifold. I have got a session, area here where I will be talking about manifold. Also, you will see that curvature, length, area changing under curves, integrals, geodesic, tangent planes. So a lot of things will be clear. So just like Shomajit is reading in class 11, so Shomajit, your way of learning calculus will be better. So all the curvatures, surfaces, structures, geometrical shapes, when you apply calculus on those areas, you will see you are learning much better. So that is why you need to learn calculus. Also, here you will see that a sphere has a positive curvature. This has got a zero curvature because they are learning parallel. This has got a negative curvature. So all these curvatures, which looks like Euclidean space, etc., here we are using also calculus. So we take a kind of an area, which I have noted as dA, differential area. You can divide this differential area into very small infinitesimal pieces, and then you can apply the rule of calculus. So that will also become very, very important for so as I told you, that learning calculus will also be enhanced. Okay. Then you will see that there is something which is called a smooth function, differential function. I'm not going to go in that. Then that would be a session for teaching differential geometry. So these things will also be very, very important. So here in this right hand side of this slide, you can see that this is a continuous derivative because it is smooth, and the other one, those black boxes, these are differentiable structures. So that is why it is differentiated. So f is differentiable, F prime x is continuous, so we deal with continuous functions, differential functions, smooth functions. So even the learning of calculus, I'm repeating again and again, whatever the way you are learning calculus, that will also be much better. The learning of the calculus will also be much better. So next we come to the part that, okay, we understand that calculus is very, very important. But what are the areas of calculus which will be important? Remember, for any part of physics or mathematics that we are learning, if you're using a tool, here we are using what? We are using calculus. So you need to understand that obviously you need to learn calculus in a very deep way. But the question is that which part of calculus is important? Certain parts are very, very important and the rest of the part is important. So here, which topics of calculus are more pertinent? That means which are the topics that you have to pay really good attention? So here is the answer. The first thing is that partial derivatives are extremely, extremely important. Okay, because ordinary derivatives will come, but mostly we will deal with partial derivatives. So slopes and tangent planes and directional derivatives, you need to have a very good understanding of partial derivative. Also you will see vector calculus will come, because div, grad, curl, these things you have learned in physics. But for example, representing geometric objects, etc., vector calculus will also come. So again, using calculus and vector calculus. Good evening, sir. When you conclude this live stream, just cover how to pursue research in this subject. I have a BSc and MSc in mathematics, but not able to qualify net paper. Okay, so Abhishek, when you how to cover pure research in this subject, I will cover up later. I will try to cover up in today's session, but this session is very important because those who are a beginner and who are learning calculus or differential geometry, I'm trying to give them a kind of a guideline. But I can make up a session separately where research in differential geometry, how it will be covered, I will definitely do. Thank you for the suggestion, Abhishek. And multiple integrals, very, very important. That a single integral won't work, so we need to come in play for volume, structure, shapes, spheres, etc. So definitely we need to know what is a multiple integral, and differentiation and differential equation. Obviously, no doubt in that we need to know differential and differential equation, because the how functions change, how motions go along curves and geodesics, etc. So all in all, what we can say is that partial differential equation very important, multiple integral very important, vector calculus also important, and differential equations, first order or second order differential equation, I mean to say partial differentials will cover up that is also very, very important. A quick note is that if you are willing to learn Green's theorem or Gauss's theorem, you can do that, but it is not absolutely essential, because in an initial differential geometry course the focus might be on manifold, etc. But you can learn or you cannot, it depends upon you. Green, Stokes or Gauss's theorem, it is well, it might be mandatory, it might not be mandatory. So now that we have learned that we need to learn calculus very much, and we have identified what are the areas that we need to know more and focus more on calculus, now it is the time that I would like to tell you what are the best books for calculus. Again, as I told at the beginning of today's video session, is that I will be talking about multiple books, but no, you don't need to purchase all the books. It is a step-by-step approach. So what are the recommended books for calculus? Here, first I will start with a very, very simple book, very, very easy and very simple book. It is widely available at Project Gutenberg. You can search out this book in Project Gutenberg. It is legal and you can download it. Okay. It is called Sylvanus Thompson and Gardner's Calculus Made Easy. Okay, remember this is a book for absolute beginners. It does not contain any partial differential equation, and I think that even a class 4 or 5-year student can start learning calculus. It is beautifully made. It takes you step by step. It gives you an intuitive understanding, and it gives you I mean to say a fabulous understanding of calculus. Again, it is for the beginners, so don't expect that there are many examples or difficult examples, etc. But initial simple ordinary differential equation and in integrals, these are covered. Again, the books doesn't contain partial differential equations. But if you want to start calculus, As a beginner, without any guide, without any professor, this is the book for you. Now, the next book that I'm going to talk is a all-in-one book. You remember, we always tell that give me one book which contains everything. Okay, one-stop solution. Like you go to a shopping mall and from pin to elephant, you can find everything. Now, if you're looking for such a book, I would recommend you to go for this book. It is more than 1,000 pages, but it is a fabulous book. Okay, Early Transcendentals, Thomas Calculus. And don't go by the Amazon rating. Amazon ratings are always not good, but this is one of the best book. It contains partial differential equations, simple differentials, ordinary integrals, intuitive concept, pictures, photographs, whatnot. You can learn everything about calculus in this book. So it is one book which teaches you everything. It covers everything that you need to know, lot of illustrations. And the last point, please note, it is very important that it goes deep to make you understand everything, and it assumes you know nothing. Now, many times in my earlier lectures in physics for students, and then when I talk to students, I always tell that try to select a book that assumes nothing. Now, say for example, today if I assume that you know certain level of differential geometry, can I read this book without any guide? Yes. Shomajit, you can very well read the first book, which I told you, Thomas Early Calculus, and the second book. And I can tell you that without guide, it is possible. You really don't need to have any professor, anybody. I can guarantee you this much. I'm telling you over live session. I've read this book. It is an absolutely great book. Okay. So I always tell for Shomajit and for others who are listening to me today or later, I have spoken that try to select a book which contains or which has number of pages or more, and it assumes nothing. Assumes nothing means it starts teaching you right from ground zero level. And this book is the book which you can start with ground zero level. So we cover two books important. One is this one, the first one, this one. This is super simple book, but very ordinary book, but it gives you a very good starting point of calculus. And then this book is a one complete book which will teach you everything. Oh, hey, Shounak, good to see you, Walter. Okay, thanks for the live stream. Welcome, Walter. You're absolutely welcome. So now that we have learned about what is called calculus as a whole calculus, now we will be going to the important parts of calculus, which is important for differential geometry. Okay. The first book would be by these two authors. I always tell that learning the authors are also important. Partial Differential Equations by Yehuda Pinchover and Jacoba Rubinstein. You can go to Google Scholar and type out Yehuda Pinchover. He's an excellent scholar, is a very well researched person, is a professor. Okay, so this book is very well written. First book for partial differential equation, lot of exercises. Okay, and it also gives you a hint of modern tools. It is very well explained, and both the authors have done a great job. Okay, I am just giving you a basic idea so that you can, I'm changing the layout a little bit so that you can see now the screen a little bit bigger. Now here is the overall, what I would say, the overall content. It starts, you can see, with introduction, and then it goes to first order equation, second order equation, then it goes into separate variables, okay, Liouville problem, elliptic equations, so on and so forth. I'm just quickly skipping through because otherwise it will take a long time. Then you can see the second part, which is also there. Here you can see that equations in higher dimension, variational methods, numerical methods, etc. All these things are covered. So I've just changed my layout. You can see me at the bottom. So this is again a very, very important book which covers up everything about partial and ordinary differential equations. The next book is a little bit, I won't say it is difficult, but it is an old book, Piskunov, which my father also constantly suggests me now also to read this book, Differential and Integral Calculus. It is a little bit older version of the book. So here you can see that it contains lot of exercises, 150 to 200 questions. It is mathematically rigorous, so this book won't give you intuitive or a clear easy understanding of calculus. It will directly start with the book. Okay, so this is also, but still I would say the earlier book you can get. Okay, now if you are willing to appear for competitive examinations like NET or GET, then you can go for this book. Again, as I told you, that you don't have to purchase this book. Each books are unique in its own way. So this is also a very good book, and it is very user friendly, good concepts. K. Sankara Rao is a very well reputed writer and a mathematician. So you can go ahead and learn this book. Another is this one, Introduction to Partial Differential Equation. This is also a very good book. This is directly for partial differential equation, little bit mathematically rigorous, so you might find it difficult to read. So if you want to start with this book. Okay, point number one. Then you can go to this book, not this one, this one, and then you can go to Piskunov's book. That would be the right process to learn. Okay, there is another book which is worth mentioning. This book is written by Denis G. Zill, and it is called A First Course in Differential Equation with Modeling Applications. Okay, so here is a quick glimpse that how beautifully the figures etc. are. And now what is important about this book is this part. If you can read it, I will be happy. Now, the author tells that I want to tell you to read this textbook, but do not read this text like a novel. Think of this as a workbook. By this, I mean the mathematics should be read with pencil and paper at the ready, because most likely you have to work your way through all the examples, etc., etc. I tell my students, when reading an example, copy it down to on a piece of paper and do not look at the solution of the book. So Denis Gisel, what he tells actually about this book is that try to do mostly the book, the exercise. So do not take it as a general book that you will just read and do. It is more of a workbook. So try to work and work more on the books. So here are a quick idea about the specification of this book. It is very clear. Okay, it has got a very step-by-step approach. That is, I think it is more than 600 pages. There are a lot of modeling applications. That means real-world applications are there. There is a huge variety of examples, and there is a practice problem. Huge amount of practice problems are there. Next book which I would like to recommend you, again I'm changing the layout. So this book is very good. Now why it is very good? Because it gives you also a little bit about the historical applications. That means how partial differential equations started, what is the need for the partial differential equations, etc. So here you can see that each section has chapter and exercises. It is a very introductory book for hypergeometric, and it also contains historic depth. I think that for students learning calculus, Zeal's engineering book has a differential book, and it is a good chunk of his complex analysis. Yeah, you can find used copies about the same price. Yeah, thank you, Walter, for your valuable suggestion. So what Walter is telling that, yes, that it is true that his differential equation book is in it is good chunk of good complex analysis, right? So here you can actually find about the details of the book, why I am recommending this book and why it is so. So here is a quick snap over about the content of the book. I'm changing the layout again. You can read through this, although I know it is very, very small, but I can tell you it contains the nature of differential equation, first order, then second order, then qualitative, then comes the Fourier series, partial differential, some special functions, Laplace information, nonlinear numerical methods, and so on. I've just given a basic idea, otherwise it would be too exhaustive. Okay. So this is what is actually we are talking about, what is called the partial differential equations, which are again very, very important for us to learn before we go and start learning about differential geometry. Now, once we have understood that these are the books which are required to learn the basic calculus, and then we start dealing with partial differential equation, the next thing that we have, you see, then when we started our session, I told there are two things which are important. One is what is called differentiation, that is calculus. Another is geometry. So we have understood differentiation, but what about geometry? So here you will see I would be talking a little bit about what kind of geometry you need to know and what is the mindset that you need to have. Now, when I'm talking about mindset, understand that geometry as itself, as a subject, if I talk about geometry, it is an intuitive concept. Okay, that means it talks about shapes, structures, and sizes, and we can close our eyes and we can start thinking that whether it is in this way or that way. So, you need to have a very intuitive and imaginative mind in order to do geometry better. So here you will see that what kind of geometry is that differential geometry builds upon certain key areas. Obviously, these are the basics. You need to know about points, lines, and planes, distance and angles, basic shapes, and coordinate system. Obviously, you need to know all things about this. But what is also important are these things. You need to have a very good understanding of spatial reasoning. Spatial reasoning means how the objects, the three dimensions, etc., how they are aligned. You also need to have a good understanding of analytical thinking, because differential geometry uses calculus. So analytical thinking and analytical foundation is very, very important. Also, you need to have thinking in higher dimensions. Otherwise, why do we need differential geometry? Euclid is good enough for us to let us know. So thinking in higher dimensions is actually an exercise, and you have to start doing that. It cannot happen in a day. So it's a constant practice, and there is a relationship between shapes. So one shape, how it is transformed, how it is rotated, etc., these things become important. So understand that this is an exercise. Also, you will see that there are many rotations and folds happen. Okay. So connection concepts with other areas of mathematics. Try to deal with puzzles, logical games, and modeling software. I remember a few days back, I was watching a short Instagram short about Professor Roger Penrose, Sir Roger Penrose. So he was using a Rubik cube, and he was telling that I made this puzzle when I was very young. So I mean to say that automatic intuitive mind or a liking towards solving logical or puzzle problems, that also is very, very important. I mean to say you need to develop on that, you need to work on that, and that is how you develop a very intuitive and a fun-loving understanding of differential geometry. So this is the level of geometry that you need to know. Now, first step, when we go in, now that we have understood the differentiation, the calculus, the books that we need, what type of geometry that we need, now comes the first step, that what is the first baby step that we need to take in order to learn differential geometry? I mean to say, what is the first concept in differential geometry that we need to understand? Many books actually straight away go to manifolds. Many books go to fiber bundles. Many books go to tangent bundles or tangent spaces, etc. But I would say, I'm not saying these books are wrong, but I would recommend that first step, the very first step in differential geometry is learning what are called curves and surfaces. Okay, that is why I have mentioned the first step is curves and surfaces, and you need to also understand the reason. Don't just believe my words, because I'm saying that why curves and surfaces are important. I will change my layout. I will go a little bit down here. Now, the first thing that you need to understand is that curves and surfaces, the conceptually it is much easier. Manifolds are a little bit difficult. Okay, so curves and surfaces are an easy way to start. Second thing is that mathematical prerequisite for learning curves are basic calculus and linear algebra. Okay, very basic. But manifolds will require advanced calculus, topology sometimes. Visualization also is easy because 2D and 3D you can visualize. But manifolds often require higher dimensional visualization. So that is why the curves and surfaces, the very first step is very, very important. Now you see there is other things that curves and surfaces, if you talk of the learning resource, say books, videos, notes, etc., they are much more in number so that you can learn easily. And the problem solving is also on very foundational and easy steps, wherein manifolds are a little bit difficult. The second thing and the last thing would be that the concept of abstract idea is very low in curves and surfaces, and manifolds are very high. And if you learn curves and surfaces, it gives you a very strong foundation for manifold. And the theoretical foundation for curves and surfaces provides a very solid grounding in differential geometry. I've seen students who have done very good in curves and surfaces. They can easily learn and quickly pick up differential geometry on manifolds later. So understanding curves and surfaces is essential for grasping the local and global properties of manifold, which we will learn later. So this completes our idea that why do we need to have curves and surfaces, and why curves and surfaces are the first baby step in starting to learn differential geometry. Now, obviously, the question comes is that which is the best book to learn? I would recommend this book. Marco Ebat and Francesco Tovena. Go to Google Scholar and type out their name. They are specialists in differential and geometry. Yeah, that is what I'm saying. What book is required, Shomajit? So this is a very good book to start with curves and surfaces. Very, very, very essential and a very good book. And why this is a very good book? These are the reasons. Very well written, good, well structured. It contains only that many amount of topics in mathematics that is required, and it assumes no advanced topic, but just it doesn't assume anything like algebraic or topology. No, and it also have supplementary materials which you can go ahead and check. Now, as I was telling that selection of a book is very, very super important. Now you can see again, I'm changing the orientation so that you can read the red lines a little bit better. So here you see that I just actually paused and made the screen a little bit bigger so that you can really read through the lines. And it says that uh, this reason section 2.1 contains a complete introduction to the theory of the degree, etc. Further, the author also writes something like this. You can see this again, and it actually tells that each chapter contains several guided problems, etc. You might have noticed another peculiar feature of this book, that we address you directly, dear reader. So it creates a kind of a nice bonding or kind of a thing. In order to learn mathematics, it is not enough to read it, you must do mathematics, and this is the style adapted in the book. Same thing, you need to know and you need to do a lot of mathematics. Here also I have highlighted few lines. It is the author is actually telling that it is does not usually find wealth of extremely interesting and important result that does not usually find its place in course, and it is sometimes hard to find it books. The supplementary materials appended to each chapter display choice of this result. We go from complete proofs of this to learn. So this is the reason that I have highlighted that this book does not assume you to know a lot of things, but it gives you a complete idea about how and what to learn about curves and surfaces. So again, a quick overview about the about the structure of this book. You can again, let me change the orientation so that you can read this. It is very simple. It starts with local theory of curves, then global theory, local theory of places, curvatures, etc. Nice, very nice book. And you can go to the next part also. You can see this, the Gauss-Bonnet theorem, which is very good. I mean to say, I've never seen Gauss-Bonnet theorem explained in such a simple manner. So this is again a very, very important book. Then it covers geodesics, etc. And this is how many? Around 350 pages. Good book enough to understand. And I've given my review what I think about this book. It is a very good book to start your fundamental concept. Easy to understand. One of the best book to start with differential geometry. And it follows step by steps. And please do not skip any chapter. Okay. Now that we have understood what we called is the understanding of curves and surfaces, the very first baby step to learn what we call differential geometry, what you also need to understand is that the geometric part, which I told that we would be dealing with geometry which is not the Euclidean geometry, but what is called a non-Euclidean geometry. So one part is calculus, that is done. One part is basically about the first step, that is curves and surface, done. Now comes the another final part, which is called the geometry. So what kind of geometry you need to know, and what is the best book to learn about going to learn ahead what geometry. So what is the best book to develop geometrical? Here I would like to tell you that this particular book, which I will now show you, this will gradually build on the geometry. Now, you need to understand one thing, my dear students, that differential geometry is something which is a very advanced step for geometry, right? So, first, what you need to know, you have to take a step back. That do I know the usual geometry very well? Question yourself. That can I prove everything in related to flat space, Euclidean geometry, parabola, hyperbola, spherical geometry, cylindrical geometry? You might find that if it is yes, great, but you might find there is a lack of this concept. Plus a video for linear algebra also. Mitsha, I have got many videos on linear algebra. It is not one. There are many videos how to learn, what are the books. Linear algebra to quantum physics, you can check, or you can let me know in email. I will send you the playlist. There are a lot of good videos on linear algebra. And on my new channel, I'm starting a complete course on linear algebra. Step by step on the matrix operation, I will start that. So not one, many books on linear algebra there. Okay. So as I told you, that you need to take a step back, that do I know those things, and how this non-Euclidean geometry evolved from Euclidean geometry. I'm not telling you learn the history. I'm talking of the development factors. That what were the problems? This is the new geometry. What were the problems? Another new theory was found. So this is a little bit older book, but as you see, that old is always gold. So this is a book which I would always recommend, even if you're not learning differential geometry. But as a human being, if you want, if you love mathematics and physics, you should read this book. Now these are the different versions I have shown. First version, second version. In Amazon, the right version, the last version, fourth edition is available. That is the what is called the black one, Euclidean and non-Euclidean geometry by Marvin J. Greenberg. This is the author, and these are the customer reviews. You can skip those customer reviews for the time being. All of them are very good. Now, what the author intends to tell you in this book is, again, I'm changing the orientation. Please read this. It tells that this is for prospective high school and college geometry teachers, are presented with a rigorous treatment and foundations of Euclidean geometry and an introduction to hyperbolic geometry. And within bracket, he writes, with emphasis on Euclidean models. General education, liberal arts students are introduced to the history and philosophical implication and discovery. That means it is not only that you are a mathematical student. Mathematics majors are also given, general education and liberal arts. That means those who have no connection with mathematics also, they can also read this book. I would recommend every single person who loves mathematics, etc., should read this book. Now you will see, he writes that if students do not do a good number of exercise, they will have difficulty following subsequent chapters. So practice, practice, practice. That is a golden rule for a class 2 student and for you also for advanced mathematics, right? So these are the sequence. I mean to say, these are the areas which I've covered. I'm just quickly skipping through, which you can later watch it. What books you showed, sir? Can I go to those books in PDF form? Shomajit, you talk to me later. Contact me in WhatsApp and email. I will try to give you something which is available. No problem. Or otherwise, you need to purchase also. Soft copies actually won't help you much. So some books you have to purchase. Yes, some books I can definitely help you out with. Okay, so it starts with logical and incidence geometry, Hilbert's axioms, neutral geometry. So again, this is a kind of a book which actually gives you a thorough understanding of how things develop. So discovery of non-Euclidean geometry, you can see Gauss's, Riemann, Everesti Galois, all those people. Geometrical transformation. Geometrical transformation means how things actually started changing. Okay, further results in real and hyperbolic geometry. So this is, again, as I told you, this is not a book only to learn for geometry, but these are the books which you also need to know as any person who loves mathematics, who loves physics, etc. Right? So these are actually, this is the first step. So you curves and surfaces gave you a basic idea about the first step for differential geometry. This book will give you a kind of a learning, a kind of a historical understanding, not historical, step by step development of differential non-Euclidean geometry, how it all started. Now I will come to another important part, that when you are learning differential geometry, you will face difficulties. Obviously you will face difficulties. So what are the things that you need to do, or what are the things that you need to have, keep it in mind, so that you don't face the difficulty? So you can say that I will be talking about what are the critical factors and what are the solutions that you need to have. So the first thing is that relies on differential calculus. So please check, recheck that your learning of differential calculus is very good or not. Second thing is that your concepts of overall calculus is good or not. Check on that. Do a lot of exercises and sums. Okay. And third is that check your old books of Euclidean geometry, which you can learn or not, which you can already have an understanding. Revise on those axioms, theorems, etc. And last thing, which is very crucial, most of the students, they avoid this and then they fail, is that whether you know what is called a proof based mathematical system. I will come to this. Please mark my words, that until and unless you have learned or have done exercise about proof based mathematical system, it will be very difficult for you to learn differential geometry, topology, any kind of a proof based mathematics system. I will prove my points, and believe me, it is through experience that I have gained. This is super, super important. So these are the things that you need to check. Now, this is also very important. It's a very common question among the students, that do I need to learn topology also? Because topology is another branch of science or mathematics, I would say, that is somehow closely related with differential geometry. Okay, somehow closely related, but it is not. But topology is a little bit, I won't say difficult, it is very intuitive. It needs your mathematical maturity. So this is a common question, that how much topology do I need to know? So first of all, you see here, I have told that differential geometry actually focuses on the studies of geometric properties. Topology focuses what are called preserved under continuous deformation. That means a coffee cup can turn into a donut can turn into a coffee cup. You can look for topology. There are several good videos. I've made a video very long for about 1 hour, where I have taken clay pots, clay models, and I have made those structured and explained all the continuous and deformation, the homeomorphism, etc., all those things. So this is what differential geometry is. Differential geometry actually, okay, let me change the orientation again so that you can read this. Would analyze the part, and topology, sorry. Yep. Topology is basically dealing with a continuous deformation. So this is a very important part. What we also see is this one. You can see that differential geometry actually and topology are closely related, but differential geometry often studies smooth manifolds. Topology uses something called differential topology. Differential geometry uses tools like derivatives, integrals, and topology mostly deals with set theory, continuous function, and homeomorphism. Okay. Finally, what we can tell you is that differential geometry is much easier to learn than topology. The reason is that differential geometry is local. So it is actually at a very small neighborhood, where the concept like curvature, geodesics are easier. Topology is much more complex, because it deals with something which is very global, and there are a lot of intricate details, etc., which I don't want to go in today's session. So the question is that, can you skip learning topology? Yes, you can definitely skip learning topology at the initial level, but it depends on what book you are searching, what book you are reading. So that is why I always tell that check out the books that you are actually selecting for differential geometry. This is a very, very important and crucial factor. Whenever you are selecting a book of differential geometry, the first thing that you need to check, that whether the book assumes you know topology. Now, if it assumes you know topology, and if you know topology, it is better. If you don't know topology, then what will happen? You have to go for another book. So here is a quick check. So first of all, check out whether the books assume that you know topology or not. This is very important. Some authors state at the beginning, some do not. Please read and check out. And if you do or do not know topology, select the book accordingly. And here is a quick checklist which you will find useful. So these are the lines which you can read. These authors, they tell that we shall not prove these assertions as a proper discussion, etc., etc. Proving global results about curve often requires deception of topology. So these are the lines will actually tell that topology is not required. So my request to you, all of you, would be check, check, check until you know that whether the books assume you that you know topology or not. Okay. Next comes what I was telling you, that do you know how to read or learn proofs? Proofs means that how will you prove that I am a human being? For example, how will you prove that Shounak is wearing a black shirt today? So anything that you need to prove given a set of axioms, given a set of hypotheses, and then, so people who are learning real analysis, they know what is a proof based mathematical system. But I am not saying that you learn all those things and then start differential geometry. It is better that you have these things under your belt. So here are few of the books which I recommend. This book is absolutely a gem. This is a gem. Anybody can read this book. Very easy book. Proof and the Art of Mathematics. This is written by Joel David Hampkins, and it is a very, very simple, almost written in English, no mathematics involved. It is a very basic proof. Why I'm telling? Because proofs are difficult. Proofreading takes time and it takes a lot of practice. Until you learn or practice proofreading, it will become very, very, very difficult. So this book will give you a very smart and a quick understanding of what is called a proof-based mathematical system. Proof and the Art of Mathematics. Okay. Real analysis, those who are learning can also take up. This is the next book, The Art of Proof. Okay. So here you can read those red lines. You have reached the stage where the details of what you already know, you need to understand them, and more advanced point of view, we want to show this is done. We will take apart that you thought you knew, and reasonably it in a manner so clear that you can proceed with confidence to deeper mathematics. So both this author, Matthias Beck and Rose Goenhagen, you can go and check out their profiles. They are absolute great masters of what is a proof-based mathematical system. Okay, this is the overall the content of the book. Okay, this is the overall content which you can check in, and I can tell you that you will enjoy reading this book. Yes, if you are learning this book or reading this part, then you will definitely enjoy and learn a proof-based mathematical system, which is going to make your life a lot easy, which is going to make things much, much easier. Another book recommendation quickly. This is called Introduction to Mathematical Proofs. This is also a very good book. And lastly, what I would recommend you is this book, How to Read and Do Proofs. This is Daniel Solo, the author. I have given the email ID also. So this book actually is a pair of lectures of willy.com. You can check this website also. It is very well written and it provides a background. I would say great explanation behind this part is given. And you can pair this book with the lectures of willy.com. Okay. And you can go ahead and check it. And these are basically what are called the content of the book. I have read it. I mean to say, I use this in various other areas of classes and lectures, etc. It is a very, very simple. So logic is also covered. So quantifiers, etc. These are also covered. So you can check out. I mean to say, there is no harm in checking out this type of books. Okay. Proof based, how to read proofs. You can later contact me also. I can tell you what are the names of the books and how you should go about it. But this is required. Otherwise, what happens is that if you start and go ahead with the mathematical system, then what happens is that you start failing after you, and then you feel frustrated. So what are the key tools that you need to have before going in differential geometry or this type of learning? I am giving you an idea. Now we will come to what we call the books to learn the foundations of differential geometry. So you can tell more or less we are done, whatever the tools that we need to have. We know calculus, we know partial differential equations, we have learned geometry, we have seen the evolution of geometry, which book of geometry is required, what type of geometry books are required, and also we have seen that in order to do a proof based mathematical system, what are the books that we need to know, and what are the intuitive and problems that might happen in learning geometry. So what is the books to learn the basic? Now we are entering the real part of differential geometry, that what is the best book to pick up. I will just tell you two books, not much to confuse about. The first book, I'm changing the layout. Okay, this book is absolutely a super book. It is Sir Lang's graduate text in mathematics. Sir Lang obviously has got an amazing book on linear algebra also. You can go through that. This is a very book. It contains the basics. It contains an intuitive understanding, and you can go ahead and start with this book. Okay, this is basically again a brief layout of this book. I know it is not visible to you, but just to tell you that how beautifully this book is designed and what are the areas that you need to know. So overall, I can tell you this is absolutely the right book to start. This will give you the right mathematics you need to start, and it is purely a mathematical book. So remember, there is no as itself intuitive descriptions or understanding which is given. The next book is called Introduction to Differential Geometry. This is by Robin Salmon. And this is again an amazing book. You can again go through the details of the book. Okay. These are all what I have given, all the text of the book. And this is actually an important part. So chapter 1 starts with a historical introduction. Chapter 2, again, foundational concept. Chapter 3, the Levi-Civitane covariant theorem. Chapter 4 again starts with geodesics. So you see that how beautifully all these chapters are arranged so that you don't face any problem. And finally, the chapter 7 and so on. So overall, I can say that book, the earlier book which I showed, is little bit mathematical. This is a very good book. Okay. It gives you the mathematical equations, length and clarify. And I can tell you this is a kind of a perfect fit for you. So these two books are basically good enough to start the real mathematics of differential geometry. I mean to say, when you start with that. Now, from here, I would like to take over another important concept of differential geometry, and not only differential geometry. This is a very important concept in advanced and modern physics also. And you can say topology also, which is called a manifold. Now, when we start learning differential geometry, you will see most of the books directly starts with manifold. Now, there is no harm. I mean to say, there is no problem in starting to deal with manifold. But if you follow this sequence, first the partial differential, little bit of history, understanding the thoughts, process, etc., then it will be easy for you to learn that why the author is talking about manifold and why these things are meant. Now, this manifold features not only in differential geometry, but in advanced higher level physics, relativity, general theory of relativity, and in various areas of machine learning, data science also. So what I would like to show you here is that what is the concept of a manifold in a very short way, because this is going to be super interesting and very important for your any kind of a career which you go ahead in terms of physics or mathematics. So understand that manifold actually contains two words. One is called a many, which means many actually, and another is fold, which means a bend or a wrap up or bending or twisting of something. So you can tell from here that manifold is that when a small area looks like Euclidean. Now let me give you an example. Again, I'm taking this cover. Okay. Now, if you look on the edge of this cover, you will see that it looks a little bit curved. This part, it looks a little bit curved. But if I keep on zooming and zooming, now if I take it close to to your camera, now you see how it is. This will become something which is a flat surface, isn't it? It's just a flat surface, right? You can see this. But if I zoom out, now you see the curvature. So zooming in, zooming out, zooming in, zooming out. So any surface, when you closely zoom in and which follows the local Euclidean law, that is what is called is a manifold. And that is what I have given over here. So person is walking on a sphere or on a surface. It looks something which is very curved surface. But if you zoom this surface, then it will look locally Euclidean. So it looks like flat, something like this. So from this cylinder, if I'm taking out those differential small elements, this would look isomorphic, not similar. Technically, it is isomorphic to a Cartesian space. So this is actually what is the point of manifold. Very important. Now, another important thing is that who coined the term manifold? And it was Bernhard Riemann. Who doesn't know about this great mathematician? Tell me. In his opening lecture in Göttingen University, remember Bernhard Riemann was a very poor person, and his father actually went bankrupt, and he sent his son to study under Karl Gauss in Göttingen. So in Göttingen, he actually first coined this German term, which I won't pronounce because I don't know the pronunciation. It actually means diversity. Okay, so he used these terms of generalizing the concept of space, introducing curvature, and he laid the foundation of differential geometry. The first book which laid the foundation of differential geometry, and he used the term manifold in German way, it means diversity. Okay, and here you can see it is a historically epic book on the hypothesis, and who translated it? William Kingdon Clifford. And who was Clifford? Clifford is known for his work on Clifford algebra. So you know Clifford algebra, that is basically why. So this person translated in English from German, and this book first got the idea of manifold. So these are actually the German terms of manifold: discontinuous, continuous, manifoldness, enfolded, extend, etc. So what we today know as manifold was introduced many years back by Bernhard Riemann. Okay, so this is how his life was, and he died at a very early age, right? So this is what is a manifold. Now, this manifold, I'm not going to repeat. There are many lectures of what is a manifold you can check out on differential geometry on this channel, General Physics for Students. I would just like to show you that there are actually different types of manifold. For example, this is a manifold. These are all manifolds. Okay, Klein bottle, etc. Nice shape and structure, solid torus, etc., etc. There are many types of manifold. But sometimes you will see that students always face a question that there are two types of manifold to start learning: a smooth manifold, a differential manifold. Okay, so which book to select, which one to go ahead, smooth and differential? I leave the decision up to you, but I just try to give you an idea that smooth manifold is actually a special type of a manifold, like Euclidean spaces, but also allows for smooth functions. Differential manifold is something which I would say is similar to smooth manifold, but it has got a little bit more flexibility. What is that flexibility? It allows for differentiable functions, which means you can take at least one derivative or maybe more. And smooth manifold also, where you can take derivatives of all orders, first order, second order, third order. But here it means that the curves and functions on a differential manifold might have some kinks, sharps, turns, etc. So in all, what we can say about is this one. I'm again changing. I'm so sorry. I'm changing the orientation. Remember that all smooth manifolds are differentiable, but not all differentiable manifolds are smooth. And why it is so? Because most smooth manifolds are most well behaved. That means allowing for smooth functions without any kinks or corners. And differential manifolds are a little bit more flexible to do. Now, this learning of manifold is again very, very important, because most of the books of differential geometry in the first or second chapter, is there anything like quasi-relativistic or semi-relativistic quantum mechanics? I can tell you about relativistic quantum mechanics, that is basically quantum field theory, but semi-relativistic, maybe that is a term that has been coined, a myth, but I have not come over. If anybody has come over, can put it on the comment box. I don't know. Relativistic QM is there. I have made videos and a lot of researches in quantum field theory, but not semi quasi particles are there, but semi relativistic quantum mechanics, maybe they're not including the real quantum mechanics, a little bit of quantum and classical, so that is why they are calling semi relativistic. I'm not sure. Okay, so so what I was telling is that if you are really serious in learning differential geometry, then you also need to learn the concept of manifolds separately. And there are just two great books of learning manifold. Okay, the first book is this person, very famous, very well known, very respected person, Loring W2, a Taiwanese American, An Introduction to Manifold. Now you might say that, shall I learn smooth manifold first or differential manifold? Choice is up to you, but I would say go for smooth manifold first. Okay, so this is the chapter overview of this book. Again, let me change the orientation so that you can see it clearly. Okay, no, I think this orientation is better. So it contains, you see that book starts with Euclidean spaces. This is again very, very important. That means it is starting with the basics, Euclidean spaces, then the exterior algebra. Okay, then it will go to manifolds. Here you can see manifolds. Okay, so it is a very good book, step by step, no doubt. This is a very important book and a very easy book to learn manifold, diffeomorphisms, etc. All these books are covered, and then you see manifolds are covered. So it starts with topological manifold, comparable manifold, smooth manifold, and then it takes into tangent space. These are essential concepts: manifold, tangent spaces, Lie groups and Lie algebras. Okay, so this is the first book about manifold, which I would definitely recommend. The second book which I would recommend is An Introduction to Manifold. This is again a smooth manifold, and this is what I was talking about. Very easy, very simple, and easily understandable. The next book is also very famous, John M. Lee, one and only book which actually still is the best in the market. I mean to say, I think this book will be best for the coming 100 years also. I can tell you this much. Introduction to Smooth Manifold. And just read out this. Again, I will change the orientation a little bit. So what it tells about this book is important, that this is for first year graduate. Okay, and you should have a solid acquaintance with general topology. You now see that I was talking that before checking or selecting the book, check it whether there is topology or not. So this book assumes you know general topology, fundamental group, covering spaces, this, etc. Okay. I try to keep the approach as concrete as possible. There are pictures, intuitive discussions, and the concept, abstract concept, but without taking away from the powerful tools. So this book actually gives you an idea that what is the target audience, first year graduate. You should know general topology. Okay, so these are basically the I would say the type of content which is covered, tensors, etc., differential form. So if you talk to me, I would say that first go for the left hand side book of Loring W2, Introduction to Manifolds, and then you can go to smooth manifolds. If you're a person who wants to learn from internet, then you can go for this website. I picked up Advanced Calculus and Differential Forms approach by Edwards. Are differential forms? Oh yes, oh yes, oh yes, Walter. Differential form again is a very, very important concept. Just to tell you, uh, not on a very simple or a basic beginner level, but if you are willing to learn differential geometry really, then differential forms is important. And I know that it takes time to absorb differential forms, and there are advanced topics with me. There are some books with which talks of differential forms, definitely, right? So you are very right, and you can support me on my channel becoming a member, or with a thank you, but the thank you part also. But yes, it is important, definitely it is an important topic, and differential forms are dealt with many books with very important part. And I would definitely recommend you that if you need any assistance in differential forms, you can contact me over email. I will do that. Okay, so first is this, the University of Notre Dame. It has got very good lectures, PDF files which you can download and read. This is actually a very exhaustive coverage of smooth manifold. This is actually from the university, so there is no problem in terms of authenticity. You can go ahead and read it. Then comes MIT Open Courseware. Obviously, there are lecture notes, PDF files which you can go ahead and read it. Then comes another part, which is this one, mathematics. Okay, then you can go for this one, ISA mathematics, lectures on smooth manifold. This is also very good. Now these are all PDF files, right? These are actually all PDF files which tells. And yeah, so that's it. This is the lectures on smooth manifold. So what I can tell from today's session is that first, understand the division of differential geometry. This will give you an understanding and will help you assess your current knowledge, learn the basic concepts the book suggestions as given. Learn the concept of what is a manifold. Also understand what is not a manifold. I have not covered this one. Trefoil knot. Okay. Then trefoil knot. I remember another is what. Uh, I don't remember the figures. There are certain there are certain figures which are not a manifold. Understand what is smooth, what is differential. My suggestion would be to start with smooth manifold and go through the books on the resources that best suits you. That means whichever you find to be great. So that's it for today's session. Thank you very much for watching today's session. You can subscribe and support me on my channel, and you can also subscribe to my other channel, General Relativity Explained, and you can contact me at this email ID. And if you have quick questions, I think I have answered all the quick questions. So I think that I have never done a live session on differential geometry learning process. So you can now very well go through it. So first step would be calculus, differential calculus, then go ahead with non-Euclidean geometry. Pick up Marvin J. Greenberg's book, that is excellent. Learn differential geometry. Yeah, hi Raghav. And then go ahead with learning basically picking up a good book on differential geometry. Go ahead with that. If you are very serious like Walter and others, speak up books on manifolds and differential forms. That is also something very good. And you can check out the lecture notes, etc. Go to my channel, Physics for Students. You will find few topics on the basics of differential geometry, some topics on what I called how to learn manifold. There are a few exclusive videos on how to learn manifold, etc. On the 30th, that is next Sunday, coming up a very, very important podcast with a gold medalist on general theory of relativity and cosmology, Professor Dr. Madhu Krishna. She will be coming, and I'm looking also forward for that podcast. I welcome you all. This would be on this channel, not on my other channel, and we will speak a lot about general theory of relativity, Roy-Choudhury equation. And if you want to have a understanding about some of the concepts of general theory of relativity, mathematics, books, career suggestion, researchers, etc., you're all welcome. Some books on particle physics. Well, okay, that is a very good suggestion, Raghav. I have already made a short video on particle physics. It is a very good suggestion. I would also request Raghav, go to my podcast list, and you will find very good podcast on particle physics. I remember the first was Professor Dr. Sudeshna Ganguly from Calcutta. She is working in Fermi Lab, and she has got a very detailed podcast on the basics of particle physics. The second one on particle physics, who was this person? Dr. Alessio Mastrodi, a very good teacher, and spoke about particle physics. And what else? Large Hadron Collider, that is also on particle physics. These two are very good. Sudeshna Ganguly and Alessio Mastrodi. Go ahead to my podcast and you will find out very good reviews on concepts on particle physics. Yes, I will do a very good review on particle physics also. Although I do not plan to teach particle physics on this or my other channel, but I have got a liking towards particle physics. Thank you very much. See you on next Sunday on this channel starting 8 o'clock with a very important podcast on general theory of relativity. Please do subscribe and put up your comment on this session so that many people can actually watch this podcast, so that my objective is to reach out and teach more people on the complex concepts of physics and mathematics. That is better. Sir, give some suggestion on basic special relativity for class 11. Okay, wait, Shomajit, I am giving you special relativity, right? Okay. Just to be there, I will just hold on. I think videos. So, okay. Here is a quick, not quick, it is a very detailed, almost 35 minutes. This is a very good video, Shomajit, which is going to make you understand everything about special relativity. Okay, just check out this link. It is from the other channel. In this video, I have given the idea of what is special relativity, why you should learn special relativity, and not one, two, three, four books on basic special relativity. For class 11 and 12, this is the best book. You can check out this video. Do not pick up the books randomly. First, go through the video, watch it, try to understand what is the reason that I am doing this. Okay, and then you can learn special relativity. Very basic books, very good books. Without any tutor you can learn. And if you are stuck up, email me what are the problems that you are facing. I will help you out, right? So Somajit, you got your answer. Raghav, particle physics is already on. Walter, I have already answered your question on differential form. So that's it. I hope you liked today's session. So Raghav, how do you think about today's session? Any comment? Anything? Walter, how do you find today's session? Somajit, I think you're the first one who is watching this session, or maybe you have come earlier. What do you think? How was the session? Any comment to encourage me? You can put it up in the comment box. I can just flash it on the screen. It looks good also. Anyway, so that's the plan. That's the plan. Thank you, sir. Thank you very much. That's the plan. A lot of new plans coming up. Another thing, another quick thing. I just made a very good podcast with one of the new space research organization. But this is not only on general relativity. It is general relativity, black hole, and astrophysics. Okay, I'm just giving you the link. It was done only yesterday. You can just watch this one if you're interested in formation of black holes and dark energy, etc. I can just give you the link of that one. This part, you can just quickly check it. This is one of my student on his channel, Agnirath Aerospace. You can check this one. Okay, Walter is telling it was a very good. You provided a detailed roadmap. It is hard to navigate all of this. It is a hell of a service to us. No, it is not hard to navigate. It is just a one by one step. This is another podcast, not a podcast, a webinar, which I did with Agnirath Aerospace. It was basically on general relativity, and they were basically from space science. Although I don't know anything much about space because I'm a person purely from physics and mathematics. So Mark Bors is telling good. Thank you, Mark. Thank you very much. Please put up the comment on the comment box also. So this podcast you can also watch. This is more on astrophysical particles, astrophysics, etc. I am not much in what I called space science. I don't know much about space science. I am person purely from mathematics and physics background. So, and for Somajit, this is the one which will give you a special relativity. So thank you very much. Take care. Stay happy. Stay safe. Do a lot of exercise. Eat good food. Be positive. Learn a good lot of physics and mathematics. Stay away from wrong things. Do a lot of concentration. Eat food, good food. Keep yourself healthy, because that is the key to do a good mathematics for a long number of hours. Thank you very much. Take care.